Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class, a stereochemical aspect of nucleophilic substitution reactions. Last class I have discussed SN1 and SN2 reaction, and also I solved some problems. Now I am going to discuss stereochemical aspects of nucleophilic substitution reactions. A SN2 reaction proceeds with a complete stereochemical inversion, while a SN1 reaction proceeds with racemization. Two terms are there. First term is stereochemical inversion. A SN2 reaction, SN2 means second order reaction in one step, that I am talking about. A SN2 reaction proceeds with complete stereochemical inversion, while a SN1 means first order with two steps. A SN1 reaction proceeds with racemization. In order to understand this concept, we need to learn some basic stereochemical principles and notation. What type of notation? Then that is the optical activity, chirality, retention, inversion, racemization. These terms, these are the actually notation. We have to understand. One by one, I will discuss all. First, I will discuss optical activity. Plane polarized light and optical activity. About that, first we should understand what is the plane polarized light and what is the optical activity. Actually, these concepts are very, very important. Question is asked. Listen carefully. All terms are very, very important. Certain compounds rotate the plane polarized light. This how this plane polarized is produced? Then plane polarized is produced by passing ordinary light through Nicol prism. Correct? A certain compounds rotate the plane polarized light when it is passed through their solution. Such compounds are called optically active compounds. The angle by which the plane polarized light is rotated is measured by an instrument called polarimeter. If the compound rotates the plane polarized light to the right, that is the clockwise direction, it is called dextrorotatory. It actually is a Greek word, Greek for right rotating, that is the dextro. This is a Greek word, means right direction, right rotating. Or it is also called in short form D form, small d, D form, and is indicated by placing a positive sign before the degree of rotation, like plus 120, plus 130, like that way. Correct? Again I am telling you, the angle by which the plane polarized light is rotated is measured by an instrument called polarimeter. If the compound rotates the plane polarized light to the right, that is the clockwise direction, it is called dextrorotatory or the D form, small d form, and is indicated by placing a positive sign before the degree of rotation. If the light is rotated towards left, means anti-clockwise direction, the compound is said to be laboratory or the L form, small L form, and a negative sign is placed before the degree of rotation. Such positive and negative isomers of compound are called optical isomers. Optical isomers. Such positive and negative isomers of a compound are called optical isomers, and the phenomena is termed as optical isomerism. Correct? Here compounds actually rotate the light. Compounds present in the solvent, when light is passed through this solution, then this compound like sugar, maybe glucose, maybe fructose, then this may rotate the light either right direction or left direction. Then these are also called, when it is you can say rotates right direction, then it is called dextro, D-E-X-T-R-O, dextro, rotatory. And when left direction, then labo, L-E-B-O, labo, rotatory. Okay. And dextro means a small d, it is represented by a small d, and labo, a small l. And for positive sign, for the it is given for right, and negative sign is given for left. Then these two forms are called isomers because formula will be the same. Formula, both have same formula, only it behaves differently with light. That's why it is both are called optical isomers. And the phenomena is called optical isomerism. Question is asked. Okay. Now I am telling about the asymmetry. What is the asymmetry? Molecular asymmetry. Second important term. You can understand three terms. First, molecular asymmetry. Second, chirality. And third, enantiomers. All three are very, very important for all examination. Correct? Related to chemistry, every time, everywhere, these things are asked. These terms, all three are related. Molecular asymmetry, chirality, and enantiomers. Now listen carefully. The observation of Louis Pasteur, he was the scientist. Actually, he has done his experiment in 1848. What he observed, that crystals of certain compounds exist in the form of a mirror image. Mirror image already I have discussed. First time Louis Pasteur has observed that crystals of certain compounds exist in the form of mirror image, and this led to the foundation of modern stereochemistry. This is the basic. Okay, this is the, you can say, foundation. His observation that crystals of certain compounds exist in the form of a mirror image laid the foundation of modern stereochemistry. Correct? Mirror image you are knowing. When you are seeing your face in mirror, then you are the original, but in the mirror you are seeing one face. And what is the difference in both original and that? That you have to understand only. All things are same. Only it will be not superimposable. Direction is opposite, not superimposable. Suppose that also comes out from the mirror and it will stand just near you. Then how both will not superimpose? That is called, that is mirror image are not superimposable. Then now this concept, this observation actually laid down the foundation of modern stereochemistry. He demonstrated that aqueous solution of both type of crystals showed optical rotation equal in magnitude. Okay, equal in magnitude. Actually, for solution of equal concentration but opposite in direction. That you have to understand. Okay, he demonstrated that aqueous solutions of both types of crystal showed optical rotation equal in magnitude. Equal in magnitude means for solution of equal concentration but opposite in direction. He believed that this difference in optical activity was associated with the three-dimensional arrangement of atoms. Actually, this three-dimensional arrangement actually is called configurations in two types of crystal. What is actually this difference? Then actually this optical activity was associated, he observed, optical activity was observed with the three-dimensional arrangement of atoms. The meaning of three-dimensional arrangement of atom is that it means how x-axis, y-axis, z-axis, how it is arranged. Correct? In a space, if you will keep that crystal, imagine, then x-axis, y-axis, z-axis, how it is arranged. That is very, very important, because here number of atoms will be the same, number of bonds will be also the same, all things will be the same, only they will be in opposite direction. Correct? Then he means here Louis Pasteur believed that this difference in optical activity was associated with the three-dimensional arrangement of atoms in two types of crystal. Then this three-dimensional arrangement of atoms is called configuration. Okay. Then another scientist, Dutch scientist, J. Van Top, you might have heard the name, and French scientist Level, L-E-B-E-L, Level, C. Level. In the same year, means 1874, these three scientists, Dutch scientist J. Van Hoff and French scientist G. Well, B-E-L, Well, in the same year, independently argued that a spatial arrangement of four groups means here valencies around a central carbon is tetrahedral. Correct? Both scientists just independently argued by their experiment that the spatial arrangement of four groups means that like a carbon with a carbon, four different groups may be arranged. Okay, then four group means valencies, four valencies, different four groups around a central carbon is tetrahedral, and if all the substituent attached to that carbon means ligand, you can tell, if all the substituent attached to that carbon are different, not the same, one may be methyl group, other may be butyl, propyl, alkyl, four groups are attached, four are different. Correct? This you remember. This scientist has focused on that. Okay, first is tetrahedral, that a spatial arrangement of four groups around a central carbon is tetrahedral, and if all the substituents attached to that carbon are different, such a carbon is called asymmetric carbon or a stereo center. Question is asked, what is the asymmetric? A, symmetry is there. A you write there before the symmetry. Asymmetric, ASYMMETRIC. Asymmetric carbon means all four, first it is tetrahedral, four groups are attached and all four groups are different. Then it is that carbon is called asymmetric carbon or a stereo center. The resulting molecules would be lack symmetry and is referred to as a symmetric molecule. That entire molecule will be called, means that carbon including four groups, that will be called asymmetric molecule. Means resulting molecules should lack symmetry and is referred to as asymmetric molecule. The asymmetry of the molecule is responsible for the optical activity in such organic compounds. Now we understood that for the optical activity, that what is the responsible? Then this asymmetry of the molecule is responsible for the optical activity in such organic compounds. Correct? Now you understood what is the asymmetric. Now further you understand. The symmetry and asymmetry are also observed in many day-to-day objects. As for example, a sphere, a cube, a cone are all identical to their mirror image and can be superimposed. Symmetry and asymmetry are also observed in many day-to-day objects. First example, a sphere. Second, a cube. Third, a cone are all identical to their mirror image. If you see in the mirror image, it will look like same and can be superimposed because it is the same. A sphere is there, then both sphere will look 100% same, no opposite. Cube also same, no opposite. Cone also same, no opposite. It is superimposed. However, many objects are non-superimposable or their mirror, or you can say non-superimposable on their mirror image. For example, your left hand, your left and right hand look similar, but if you put your left hand on your right hand, they do not coincide. It will both left hand and right hand look similar, but if you put your left hand on your right hand, they do not coincide. The objects which are non-superimposable on their mirror image, like a pair of hands, are said to be chiral. CHIRAL. Chiral means non-superimposable, none, left hand and right hand. Okay, the objects which are non-superimposable on their mirror image, like a pair of hands, are said to be chiral, and this property is known as chirality, while the object which are superimposable on the mirror image are called achiral. Which are superimposable, asymmetry, that is called achiral. A small a, CHIRAL, achiral. and chiral means non-superimposable. Difference you understand? Chiral means non-superimposable, just like your both hand, left hand and right hand. And achiral means asymmetry. Okay. Then this I have told you. Now two new term. Okay, that is the chiral and achiral. Then this actually what is the chiral I told you, and this property is known as chirality, while the object which are superimposable on their mirror image are called achiral. Correct? Now this test I am talking about, this test of molecular chirality can be applied to organic molecules. These tests, superimposable, not superimposable, this test of molecular chirality means non-superimposable chirality you are talking about. Then this test of molecular chirality can be applied to organic molecules by constructing models and its mirror image, or by drawing three-dimensional structure and attempting to superimpose them in our mind. Just you have to imagine, only then you will understand better. Just you can make some model like that, you can see how it is imposing or not, superimposing or not. You have to think. There are other sides, you can say this other way also you can understand. There are other aids, however, that can assist us in recognizing chiral molecules. Chiral molecules means having different groups, that carbon, that type of molecule, chiral molecules. And there are other aids, however, that can assist us in recognizing chiral molecules. One such aid is the presence of a single asymmetric carbon. Now just example I am telling. Let us consider two simple molecules, propane 2-ol means second carbon, oxygen, OH is there, and butane 2-ol means on the carbon number 2 alcohol is there, but it is the butane. And first I told you propane 2-ol, three carbons are there, carbon number 2 OH group is there, and here in butane 2-ol carbon number 2 OH group is there. And now just see their mirror image. Then what you will find? That now in mirror image, correct, that carbon I told you, this suppose in this molecule you have to rotate it. Okay, CH3 actually total 3 carbons are there. Propanol I am talking about. CH, then there you understand that with the central carbon OH and H is attached. Correct? H and OH is attached with the center, and first and last CH3 is there. In the middle carbon is there, and with that carbon H and OH is attached. Now if you will see this molecule in mirror, then what you will find? That carbon, suppose this propanol I am talking about, suppose this CH3 was just like both methyl group are just like a backside. OH was in the front and H was just along with Ca methyl group direction only. Only OH is in the front. That you can consider. CH3, 2CH3, that is backside. Just to think, imagine. And H is also backside. OH is in the front. Up, that in the front. If you will see the image of this molecule in mirror, then what you will find? That OH which was close to mirror, that in mirror also it will look like that it is in the front. Just like your hand you are putting there towards the mirror, then mirror will also will see one hand, correct, towards your direction only in the beginning, before your body. Same things here, molecules you will see that OH will in mirror also it will look in the front but in opposite direction, and this CH3 and H, it will look behind in mirror also, correct. And if you will rotate this mirror image again by 180 degree, then again you will get same like original. 180, now you have that mirror image. Now suppose you have rotated by 180 degree, then again you will get same molecule you will get original. Okay. Then C obtained by rotating B means third. First is A diagram, second is B, and again it is coming to the original, that is a C. Then C obtained by rotating B by 180 degree. Then you can tell C is superimposable on its mirror image A because A is also same, C is also same like original, then both are superimposable. But B and C, they are not superimposable, or A and B are not superimposable. Then this I have told you, but you have to imagine in mind, that is better. As you can see very clearly what I discussed now, or you can understand, propane 2-all does not contain any asymmetric carbon because this propane 2-all does not contain an asymmetric carbon. Why? As all the 4 groups attached to the tetrahedral carbon are not different. Okay, it is not asymmetric. For the asymmetric, all should be different. But there 2 methyl group is there. 2 is different, 2 are the same. OH and H both are different, but methyl both are same. Hence, you can tell does not contain an asymmetric carbon. Correct? As all the 4 groups attached to the tetrahedral carbons are not different. Different means chiral, asymmetry. Okay. Then this you can tell that propane 2-all does not contain an asymmetric carbons because all the 4 groups attached to the tetrahedral carbon are not different. Thus it is an achiral molecule. Question is asked. Correct? Now I will tell this other example I am telling you, then you will understand. But other example I am telling you. Now you just think this 3. Again butanol, second carbon OH is there, just like a propanol. Here also carbon number 2 OH is there. But now one group is CH3, other group is C2H5. C2H5 means 2 carbon is only here under the C2H5. Then one is H, other is OH. Correct? Same way what I discussed with propanol, here also same way. Then now here again same type of a structure will get. OH is there. In mirror you will get again OH in the front, and this CS3, C2H5 which and H all were in backside. It will look also backside in mirror. Then second this mirror again, suppose first you just you consider as a D, and mirror image you consider as a E. Then again, now if E mirror image, if you rotate by 180 degree, then again you will get same actually form, same molecule you will get like D original. Correct? Means F last, DEF last, that you got it after rotating 180 degree. Then this F obtained by rotating E, second you are rotated, then you got rotated by 180, then you got F. Correct? Just same like first one. Then here also F, here now you can see F, you will see here none superimposable on its mirror image D. Here you will find this C, because here all four groups are different. All four groups are different. One is methyl group, other is ethyl group, third one is H, fourth one is OH. Then here in mirror image you will see OH in the front. Correct? And these three went back. But what you will find that these three went back, but you will find it is just back three molecules, means methyl, ethyl, H. Their direction is a little different. Their direction is a little different. Okay, not the 100% same like propanol. And here E, if you will rotate, then what you will get? That will not get like these things, propanol. In propanol you got same structure after rotating 180 degree. But here you actually, here also same molecules are there. Back is coming back only. It will come like original, but it is not the original. It is actually not original. You will find that CS3 went to the C2H5 plus, and C2H5 went to the CS3 plus. Angle different you will find. Angle different you will find. Why? Because here all poles are different. It is asymmetry. Correct? Asymmetry means achiral. Correct? Here all four are different. That's why here E is none superimposable on its mirror image. Correct? Butane 2 all has four different groups. Correct? Butane 2 all has four different groups attached to the tetrahedral carbon and is expected a chiral. And is expected chiral, you can tell, don't confuse with here. CHIRAL, because four groups are different, that's chiral. Correct? Both are different. That's why it is called chiral. Remember, different means chiral. Correct? They always remember that all groups should be same. Then you can tell is chiral. Okay? And this property is called chirality. Then this butane 2 all, it shows chirality, non-superimposable, but propane all, which has you can say this two groups same, all groups are not same. That's why they are superimposable and called achiral, a small a, chiral, achiral or achirality. If not the, if all are same, or simply you tell if all are different, tetrahedral, all four groups are all are different, then chiral. This you remember. Only this you remember. Obviously, achiral means there may be two, maybe same, two may be different. Okay, all are not same. If all are not same, then chiral. All are different means chiral. Correct? If even two groups are same, then it will be not chiral. It will be achiral. Then propanol is the example of achiral and butanol is the example of chiral. Their isomers are optically active. Okay. Now I am telling you some common examples of chiral molecules having different groups. Then examples I am telling you such as 2-chlorobutane. Remember example 2-chlorobutane and 2,3-dihydroxypropanol. 2,3 carbon number 2 and carbon number 3 OH group is there. 2,3-dihydroxypropanol, aldehyde. Okay, if you see the molecules, then you will find that 1,2,3-dihydroxypropanol. Al means aldehyde. Then here you will see total how many carbons are there. Then 1, 2, 3, because it is a propanol. Then one will be obviously CHO group will be there. One group is CHO. Correct? With the central carbon, one is CHO, other is OH. 2, one is only H. 3, and other is CH2OH. CH2OH itself is a one group. CH2OH. Then here 4 different groups are there. First is CHO, other is OH, third one is H, fourth one is CH2OH. CH2OH itself is a group. Okay. Then these 4 groups are different are there. And 2-chlorobutane also you will see all are different. Then these are the example of chiral. Question is asked. Again I am telling you examples. 2-chlorobenzene, 2-chlorobutane, not benzene. 2-chlorobutane, first example. Second example, 2,3-dihydroxypropanol, aldehyde. Okay. And other examples I am telling you, bromochloroiodomethane. You can see simply by seeing the molecule, you can understand that with the tetrahedral, one carbon is there, then what are the groups attached. If all groups are different, then it is a chiral. By seeing the molecule, you can understand. Even in examination, you can understand that all 4 groups are different or not. If different means chiral. Just very simple way. But here, for your just information, I am telling you another next example. Bromochloroiodomethane means all are 3 bromo, chloro 2, iodo 3, and 1 H will be there. Methane means with carbon 1 H and 1 bromine, 1 iodine. All are different. With carbon 1 bromine is attached, 1 Cl is attached, one I is attached 3 and one H 4. Correct? Next example I am telling you, 2-bromo-proponic acid. 2-bromo-proponic acid. Then now you can understand 2-bromo. 5 with central carbon 4 are attached. Now see here also all are different. 2-bromo means with carbon number 2 bromine is attached. Okay, and one group carboxylic acid is attached. Correct? I told you example 2-bromo propanoic acid. Propanoic, total 3 carbons should be there. Then one is COOH because it is acid, other is bromine. Now 2 group is over. Third one is H, fourth one is CH3. Then now all groups are different. One methyl group, one bromide, third one is COOH, fourth one is H. Then these are the examples of chiral molecules. Okay. In examination, many students are getting confused, are doing wrong. But now I told you, by seeing only you can understand whether it is a chiral or achiral. If all are different, then chiral. Only this you remember. Automatically other will understand. Now further I am telling you other terms. The stereoisomers related to each other as a non-superimposable mirror. Non-superimposable mirror image are called enantiomers. Now don't confuse. Now I will explain you. The stereoisomers means now both mirror image and original both are stereoisomers. Okay, optical isomers. Now you try to understand here. The stereoisomers related to each other as a non-superimposable means mirror image and you non-superimposable, left hand, right hand. Your leg also, left leg, right leg. Correct? This hand and leg both are examples of non-superimposable. Okay, non-superimposable. Then now I am telling you original and mirror image. Correct? Means left hand, right hand, left leg and right leg. I am telling you like that. But always with molecules you can't tell like that. You can't tell like that, left, right. Okay. Then what you will tell with these two pairs which are non-superimposable? What term you will use for both? For both, what you will call? Isomer you are telling, okay, stereoisomer. Then here particular name is there. So that original and mirror. Suppose both are non-superimposable. Then both will be called enantiomers. Mirror image also enantiomers and original also enantiomers because both are non-superimposable. And these two molecules will be called enantiomers, means a pair. Pair will be called, both molecules will be called enantiomers. Correct? It is just like a name only. Both non-superimposable molecules, isomers name is called enantiomers. Both are enantiomers. The stereoisomers related to each other as a non-superimposable mirror image are called enantiomers. Question is asked. Okay. Then new term I told you, enantiomers. Now I am telling you these things. Other term I will tell you. New term quickly will understand. A mixture containing two enantiomers in equal proportion. Just listen carefully. A mixture containing two enantiomers in equal proportion will have zero optical rotation. Zero optical rotation, angle is 0. A mixture containing two enantiomers in equal proportion will have zero optical rotation. As the rotation due to one isomer will be cancelled by the rotation due to the other isomer. Correct? Again you listen. A mixture containing two enantiomers is in equal proportion will have zero optical rotation. As the rotation due to one isomer will be cancelled by the rotation due to the other isomer. Such a mixture is known as racemic mixture or racemic modification. This type of mixture means both isomers mixture whose this rotation is 0, optical rotation is 0. Such a mixture is known as racemic mixture or racemic modification. A racemic mixture is represented by prefixing DL. DL, you can write a small d, a small l, together you can write DL. Means dextro and rotatory, together you are writing DL. Means you are talking about racemic mixture. It is represented by DL, or you can tell sign by positive and negative, plus minus. Plus minus in a bracket you write, a small bracket plus minus, that is also notation of racemic mixture. Okay. Then DL or plus minus before the name, for example, plus minus butane 2-ol. Plus minus butane 2-ol is an example of racemic mixture. The process of conversion of enantiomers into a racemic mixture is known as racemization. Correct? Now you understood what is the racemization? The process of conversion of enantiomers into a racemic mixture is known as racemization. Okay. And now this term is new. All terms are asked in examination. Now one problem I will tell you. Okay. Because this type of question is asked. Only you have to identify. Identify chiral and achiral molecules in each of the following pair of compounds. Okay. Here I want to tell you that wedge and dash representation, WEDGE, wedge and dash, DASH, dash representation. Question is given, wedge and dash representation. Then black, complete dark, that is, and this dot, that is called dash. Then molecule will be represented like that. Then dark will tell about the above the paper. Correct? Group is above the paper in 3-dimensional. Just to consider, it is in a space. Correct? In air, just like you think that now molecule is in air, that is space what you are telling. Then here one molecule is up above a paper, other dot is there down, and this other two are on paper. One is above the paper, other the below paper, and two groups are on the paper. Total 4 groups. Then now dark will tell above the paper, dot will tell below the paper. Correct? And ordinary representation, line bound, what you are telling, that is on paper. Then now question is given, you have to find out chiral and achiral molecules. Then now I am telling you 4 molecules is given. Then first is very easily you can recognize. with carbon, with central carbon H, one H is attached, one methyl is attached, one bromine is attached, and one OH is attached. All are different. Then what will be this? Correct? You can understand. It is chiral because it is a tetrahedral. All are different. Okay. Now second I am telling you. Second, with central carbon 2 bromine is attached and one H is attached and one CH3 is attached. Then 2 bromine is attached. Means what? 2 bromine is attached. Then what you will tell for that? This is achiral. Achiral because it is not, you tell it is not chiral, means achiral. Correct? Now third one is little long. With one carbon, OH is attached, H is attached, CH3 is attached. And fourth one is also there long. But that is you can take it as a one group. Just like I told you CH2OH. Okay. Then with central carbon, one is H, other is OH, next is CH3. Okay. Then now here second is also second. Actually first I told you first one is actually you have to identify chiral and achiral molecules. Then first case I told all four are different. Second I told you that is only two are same. Here it is showing 2 Br is same, then it is achiral. Third one is all are different, then it became chiral. Correct? And fourth one again all are this one H group is attached, other OH, again 2 methyl is attached, 2 ethyl is attached, then again it is achiral. Correct? Then this I told you. Now one more, this I told you all I told. One more is I will tell you that now with carbon number 2 means with that carbon bromine is attached, means central carbon you can tell. Chiral carbon means you can tell that is a bromine is attached and other methyl is attached. Third one H is attached. Fourth one CH2 CH3 is attached. CH2 CH3 is attached, means ethyl. Again different, then it is a chiral. Now again you can think that here bromine is there, one bromine is there. Correct? And 2 hydrogen is attached with that carbon, and again propyl group is attached. Then propyl okay, but 2 hydrogen is there, then it is also chiral. And not 2 hydrogen same, then it became achiral. Correct? Then I have discussed there, and next class I will discuss 2 more terms are there. Some terms are important terms are there, like retention, inversion. These terms and other things are also there. I will discuss in the next class. Thank you.